everyone. Today we are going to go on with the another lesson. Fine. Now, as such, in your low classes, we learnt about some things around us. So there are different things around me. This is a duster, a pen, a glass, a book. There are certain things around us. Along with things around us, we have learnt about changes around us, which are caused because of certain substances. We have come across lots of different types of changes. For example, if you can remember, there are certain changes which are slow in nature, certain changes which are very fast in nature, some changes are desirable changes which we like, and some of the changes are non undesirable changes. Some changes are physical changes, some of them are chemical changes. So, like that, we have learned about different types of changes. Souring of a milk, change of climate, all this we have learned about. Now, all this changes are occurring because of substances which occur in nature. Now, as such, we have n number of substances. We have not yet learned about the chemical compositions of these substances. So, as such, in today's lesson, we are going to learn about chemicals and the chemical changes. We are going to concentrate on what are chemicals and the chemical changes which occur in nature. To begin with, we start with the chemical substances. What are these chemical substances? So, as such, when we are dealing with chemical substances, the first thing which comes to our mind, which I think you have already heard about it, is matter. The substance is nothing but matter. Now, how is that you're going to define matter? Matter is a substance which occupies space and has some weight. Matter is a substance which occupies space and has some weight. Now, what is matter made up of? It is made up of atoms and molecules. Heard about these words? Fine. Matter is made up of atoms and molecules. Now, what are atoms? What are atoms? Atoms are the units of matter. Atoms are units of matter. That is, the smallest particle of matter is what is referred as atoms. Now, what is a molecule then? Two or three atoms put together gives rise to a molecule. Two or three atoms put together gives rise to a molecule. Now, as such, the substances can be pure and impure. The substances can be pure and impure. But before we get into the pure and impure, here the atoms form elements or compounds, right? Elements or compounds. Now, what is the meaning of an element? What is an element? Here, element we can define where it is made up of similar type of atoms. That we call it as an element. For example, carbon. That is an element made up of only one type of atoms. For example of a compound, we can easily write or take water. It is made up of hydrogen atoms and also it's made up of oxygen atoms. So that's the reason it is a combination of two types of atoms. That's the reason we call it as a compound. The same thing, pure substances and impure substances. These are called pure substances. They are made up of water is been represented like this. Carbon has been represented like this. So thus the elements and compounds both put together we call it as a pure substances. They are called as pure substances. Then what are impure? They are what we call it as mixtures that forms impure substances. Right? We'll now go into a little more detail about elements, compounds, and mixtures. To begin with, elements. Now, what is an element? Here, it is made up of similar type of atoms. That is what we have discussed over here. Now, when we are talking about an element, it is made up of similar type of atoms. That's it. It is made up of only similar type of atoms. Then what is it? What is its doing? What is its function? So as such, when we talk about elements, they are made up of similar type of atoms. They have their own properties. They exhibit their own properties. So as such, each and every substance or the atoms present in the element exhibits the property of the element. For example, I have given carbon an example, right, of an atom. So all the atoms in the element, they exhibit the same properties, right? So as such, elements are being classified or divided into two types: metals and non-metals, right? Metals and as well as non-metals. For example, under metals you can take iron, right? That is an element. Whereas non-metals you can take carbon, oxygen, all these becomes non-metals. So as such, we define element which consists of similar type of atoms. They exhibit the same property. Now coming to compounds. Now what is the meaning of a compound? It consists of two or more atoms. Compound, as I told you previously, it consists of two or more atoms. But here they are in definite proportions. They are in definite proportions. Compounds, they consist of two or three atoms, but their combination is in definite proportions. Now I gave you an example for a compound as water. We take the same example. Now what are the two atoms present? That is hydrogen as well as oxygen. But they are present in definite proportions. That is two atoms of hydrogen and one atom of oxygen together gives rise to this compound called as water. Now here what happens? Hydrogen has its own properties, oxygen has its own properties. But when they are combining together to form a compound, so they develop the properties, they exhibit the properties of water. They exhibit the properties of water. Now understood about a compound? Fine. Another example I give you. And for example, you take iron, right? Where we are discussing about the properties. Example, you take iron. Iron usually has its magnetic effect, right? Attracted towards the magnet. That is the property. But when it combines with another atom, that is sulfur, it forms iron sulfide. Here, iron doesn't show any magnetic property. It has its own property to be exhibited. Right? So that is what is called as a compound. Now next, coming to mixtures. Now what is a mixture? Mixture, I already told you, it is an impure substances. Mixture, for example, right? You learned about solutions last year. We learned about solution last year. So here, mixture is a combination of different atoms, but the proportion is not definite. Indefinite proportion. For example, you can take a salt solution, right? There's no such proportion where it has been fixed for that solution. That is what is called as a mixture. It's a combination of many atoms, right? It is a combination of many atoms, but it doesn't show the same property. So that is why it is called as a impure. Now we'll discuss regarding chemical symbols. So how is that we are going to mention or write or learn about the chemical symbols? Why is that? You may ask, ma'am, why is that it is necessary for us to learn a symbol? To write a chemical reaction, We cannot write the complete word. For example, carbon dioxide. Every time you write carbon dioxide, you cannot write completely in a word. We require a symbol. So as such, we have till date, we have about 118, okay, 118 known elements. And that 94, right? We have 118 known elements. Under that, 94 are found naturally. Naturally, they are found. Whereas you have 24, right? 24 which are synthesized in the labs. They are found. So, one on the whole in nature, we have about 118 existing elements. Under that, 94 are naturally existing and 24 are synthesized in the labs. So, as such, we'll discuss about how is that we give a chemical symbol. So, how is that for an element? How is that we give a chemical symbol? For example, just now I have written C for carbon, water I have written H2O. So how is that? I have written those symbols. So as such, we have taken to write a symbol, to get a symbol which has been followed throughout the world. It's not that it is followed only over here. Throughout the world, the same symbol has to be used. Now how is that it is being formed? There are certain steps or there are certain methods which have been followed. So the modern method, how to write a chemical symbol. How is that we write a chemical symbol? For example, C I have represented for carbon. So what does this indicate? That is, I have taken the first letter, right? I have taken the first letter of this element and I have represented its symbol as C. Now, as such, there are certain elements along with carbon, they also start with C. For example, chlorine, cadmium, calcium, all these start with C. Now, how is that? For everything, if I write C, C, C first letter, how is that we are going to differentiate whether it is carbon or calcium or chlorine? So that's the reason, for example, if I take chlorine, I use the second letter. It has been represented like this. If I take calcium, it has been represented by Ca. Cadmium, because Ca is already taken for calcium. I go for a third letter, cadmium. Right? Here this is silent. So I go for L. So like that, a chemical symbol also can be written. First step, only the first letter. In the second, if you have the repetition, all are starting with C, then I go in for the second letter or the third letter because if it shouldn't be repeated. That is it. In the third one, if at all, we have 118 elements. So when these names were given, some of them didn't match, some of them were having the same. So they have gone for the Latin names also. For example, the Latin name for gold. Okay, Latin name for gold is aurum. So thus, gold has been represented by A. Right? So this is how we have taken or we have learned about chemical symbols. There's somewhat page number 49 in your textbook where it gives symbols of few elements. So kindly read that left, right? Go through that page. Any doubts you can get clarified during or in the class, right? After the chemical symbols, next comes the next most important is atomicity. This might be new to you, but might have heard somewhere. Atomicity. So when there's a formation, okay, the number of atoms which make up that element, right? That is what is atomicity. The number of atoms. It may be 1, it may be 2, it may be 3, it may be 4, it may be 5. So the number of atoms which is showing in that symbol, right? So the number of atoms which is present or which is forming that element is being subscribed. It is being written on the right side, subscript. That is, for example, if I take chlorine, always it is diatomic. So whenever I write chlorine, it is Cl2. That shows diatomic, which is written on the right side as a subscript. That is what is called as atomicity. So as such, we have monoatomic, that is only one; diatomic, if it is two, represents two atoms; triatomic, if it represents three atoms; tetraatomic, if it represents four. Phosphorus, when we are taking, we usually write it as P4. Ozone, we write it as O3. Chlorine, I have already shown, that is diatomic. Then coming into monoatomic, helium, He, that is mono. See, helium monoatomic, that is only one atom. Chlorine diatomic, I have written below, right side below, two chlorine atoms. Ozone, three triatomic, three atoms of oxygen. Then phosphorus tetraatomic, that is four atoms of phosphorus. That is what is called as tetraatomic, right? And this